All right, so question number 5. Susie has a painting, and it's worth $7,800, and they appreciate 1.5% annually. And what we've been able to find in the textbook with other examples that it's a compound appreciation. So it's 1.5% of the previous year's value. It goes up. That's compound, right? That's not just 1.5% of this value every year. It's 1.5% of its previous year's value. It goes up. So we're going to do compound. So how long will Susie need to keep the print until its value exceeds $10,000? Okay. Well, so first of all, let's do this. The future value, right, would be the principal times 1 plus the interest rate here, okay, to the power of n. Okay, so this is compound interest basic formula. So we are trying to get to 10,000. So how long? So how long is going to be the n, right? It's going to be how many years? So let's say 10,000 is here, and principal is 7,800, and we've got 1.5%, so as a decimal, that is 0.015, plus 1 is 1.015 to the power of n. Now, okay, so to solve for n, how do we solve for n? Well, let's do divided by 7,800 first. Okay, 7,800. So what's 10,000 divided by 7,800? 10,000 divided by 7,800. 1.28205. 1.28205. So those are gone. So now that is this 1.015 to the power of n. So here's the thing. When you're trying to solve for n like this, okay, right now in this course you haven't learned how to solve for n. I guess, yeah, technically you have. Forget that. We've learned how to solve for n. We change this. This is like an exponential, right? Remember? So we can write this as a log, I guess, a log equation. We have to use logarithms to solve for n, okay? Or you could just do trial and error. If you don't like the logarithms, you can do trial and error. But if this is a base to the power of an exponent equals a number, so remember how we make that into a log equation? Let me change my color here. So how this is the base. So let's go log, the base is 1.015, okay? The exponent is n, so n is going to be what we're equaling over here. And this is the 1.28 is this number, 1.28205. So if you can do this on your calculator, this is going to be easy. That's how you solve for n, and that will give you n, the number of years, I guess, okay, that it will equal 10,000. All right. Now, if you don't have a calculator that can put in this base, there's a change of base formula that I don't know if I've taught you this. I don't know if this is in this course or not. I'm kind of thinking it's not. But you could do this right here, okay? You could go, it's the log of this number divided by the log of this number also gets you the answer for this. So it's a change of base formula, it's called. So log of 1.28205 divided by the log of 1.015. So you could do that to solve for n, and I think that should give you the proper number. So let's just try that. And I'll summarize this change of base law at the end of this little section here. So log of 1.28205 divided by, whoops, bracket, divided by log of 1.015, and that should give us our n. So it comes out to 16.687. So if n is 16.687, we're talking about years now, okay? So how long will Susie need to keep the print until its value exceeds 10,000? Well, it'll be exactly $10,000 at 16.687 years. So she's going to have to keep it, let's say 16 years, 8 months, right? Let's go. Or 16 years, 7 months, whatever. 0.687 of a year after 16. So at least, maybe you might say 17, right? Round that up, 17 years or so. Approximately 17 years. Okay, then it'll be worth over 10,000. So that's for A. Okay, does that make sense? And does that look like agree with what you had? Okay, so that is the correct answer for A. Now, if we look at B, okay, B, it says about how long will Susie need to keep the print until its value has doubled. Well, that's the rule of 72. Okay, so 72 divided by our annual interest rate, 1.5, gives me about 48. 48. So the value will double. Okay, so 7,800 times 2 is what? 15,600. That will happen in about 48 years. Okay. So that's question number 5. Any questions about that?